Hi friends, welcome to our YouTube channel all about materials and engineering. The name has it all. The channel will be providing informative and educational videos related to materials and engineering. The sole purpose of creating these videos is to give and explain the concept of engineering in a simple manner so you understand it better and you can remember it easily. Please like and give your valuable comments about the videos. Don't forget to subscribe this channel and stay connected with us. In this video, we are going to see about the specification of hot rolled, medium and high tensile structural steel. I will explain the applicable clause of this standard IS 2062-2011. This standard was first published in the year 1962 and revised 7 times from 1969 to 2011. 2011 is the latest revision of the standard IS 2062. The Indian Standard 7th revision was adopted by the Bureau of Indian Standard after the draft finalized by the Broad Steel Product Sectional Committee has been approved by the Metallurgical Engineering Division Council. This is just an information that IS 2062 7th revision was adopted by Bureau of Indian Standard. Before seeing the standard, we can have an idea about the engineering material and the classification scheme of the engineering material. The field of engineering is concerned with the optimum use of the material. The engineers are required to select the most suitable material for their job. In order to make the optimum selection of the material, engineers should have the fundamental principle which controls the properties of the material. The engineering materials are classified into four, namely metals, plastics, ceramics, and composites. The metals are further subdivided into ferrous and non-ferrous metals. The other engineering materials such as plastics and ceramics, composites will be discussed in the different video. Ferrous metal. The metal which contains iron as the main constituent is called as ferrous metal. Ferrous metals are broadly classified into two categories: steel, cast iron. Based on the amount of carbon in the alloy composition, steel generally contains 0.05% to 2% of weight of carbon. The cast iron generally contains 2 to 4.5% weight of carbon. The steel are further subdivided into plain carbon low alloy steel or alloy steel. The plain carbon low alloy steels are further divided into three categories, namely low carbon, medium carbon, and high carbon steel. IS 2062 grade 2011 will fall under the category of low carbon steel. In this video, we will be going to see about the specifications and categories of IS 2062. Scope for requirement of structural steel. Class 1 of the standard IS 2062. The standard covers the requirement of steel, including microalloyed steel plates, strips, shapes and sections like angles, T's, beams, channels, etc., flats, bars, etc. The steels are suitable for welded, bolted, and riveted structures and for general engineering purpose. Microalloying elements. The microalloying elements are defined in the class 3.1 of IS 2062. Elements such as niobium, vanadium, and titanium are ordered singly or in combination to obtain higher strength to weight ratio combined with better toughness, formability, and weldability as compared to unalloyed steel of similar strength level. In addition of these elements, increases the carbon equivalent and welding crack sensitivity. Therefore, in order to ensure welding performance, the amount of these materials would be restrained. Weldability. The weldability of the steel is defined in the class 3.2 of IS 2062. The weldability, also known as joinability of a material, refers to its ability to be welded. A metallic substance is considered to be weldable by a given process And for the given purpose, when a metallic continuity to be stated, degree can be obtained by welding using a suitable procedure so that the joints comply with the requirements specified in the regards to both their local properties and influence their construction of the which they form a part. The grades of structural steel is covered in the class 5 of IS 2062. The IS 2062 structural steels are classified into 9 grades and 4 sub-qualities as follows. The 9 grades are E250, E275, E300, E350, E410, E450, E550, E600 and E650. The 4 sub-qualities are A, BR, BO, C. For subquality A, impact test is not required. For subquality BR, impact test is optional as per the agreement between the purchaser and the manufacturer or supplier. If required, the test will be done at room temperature. For subquality BO, impact test is mandatory and the test will be conducted at 0 degrees Celsius. For subquality C, impact test is mandatory and the test will be conducted at minus 20 degree Celsius. Now in the subqualities, I have mentioned semi-killed and killed in brackets. Now we will see about semi-killed and killed steel. Steel is normally killed by aluminum and silicon. Semi-killed steel will be killed by silicon only, whereas killed steel, the steel is killed with aluminum alone, silicon alone, or both aluminum and silicon. Now we will see the difference between semi-skilled steel and killed steel. During solidification of semi-skilled steel, gas is evolved in the body of the ingot, tending to compensate in part or entirely from the shrinkage accompanying solidification. Pipe cavities are minimized in semi-skilled steel. This type of steel is suitable for drawing operation except severe drawing. Now we will see about killed steel. No evaluation of gas during solidification will take place. It will be characterized by high degree of chemical homogeneity. It will be marked with K symbol as an identification process in the plates. Now, for grades E250 to E410, there shall be 4 subqualities like A, BR, BO, and C. For grades E450 to 650, there shall be 2 subqualities only, that is A and BR. The chemical composition of structural steel. The table 1 shows the chemical composition of the structural steel with reference to the grade and quality of IS 2062. Carbon, manganese, chromium, sulfur, phosphorus, silicon will be the main composition to be noted in the structural steel. Chemical composition. The chemical composition of the IS 2060 can be analyzed using 2 stages. One is ladle analysis, one is product analysis. Ladle analysis. Analysis carried out of a sample taken from the ladle soon after the liquid metal has been tapped into it from the furnace. Product analysis. Analysis carried out of a sample taken from the plate of the test block separately or integrately casted. The ladle analysis of the steel shall conform to the requirements as given in the above table 1 of the chemical composition. This analysis shall be made from a test sample preferably taken during casting or teaming of the heat. Product analysis. The product analysis shall be carried out on the finished product from a standard position. Permissible limit of the variation in the cast of the product analysis from the limit specified in the above table 1 of the chemical composition shall be as follows. The permissible variation over the specified limit is given maximum in the percentage for carbon, manganese, silicon, copper, sulfur, and phosphorus. Weldability. The weldability, also known as joinability of a material. A metallic substance is considered to be weldable by a given process and a given purpose. When metallic continuity to be stated degree can be obtained by welding using a suitable procedure so that the joints comply with the requirements. Steel of quality suitable for welding is A, BR, BO, and C. For grades E 250 and 275, weldability increases from the quality A to C. Deoxidation of structural steel. Deoxidation is the process that allows for the removal of excess oxygen from the molten metal. This process involves adding carefully measured amount of such materials that has high affinity for oxygen. They attract the oxygen present in the molten steel and form oxides, thus reducing the oxygen content in steel. The oxides of these materials are either removed in gaseous form or they are readily available as slag and float on the molten steel surface, which is skimmed off. Mode of deoxidation: semi-killed or killed. For semi-killed steel, percentage of silicon should be less than 0.01%. For killed steel, there are three types. It is killed with aluminum alone, killed with silicon alone, or killed with silicon aluminum. If the material is killed with steel with aluminum alone, percentage of aluminum should be less than 0.02%. For killed steel with silicon alone, percentage of silicon should be less than 0.01%. For killed steel with silicon and aluminum, percentage of silicon should be less than 0.03% and percentage of aluminum should be 0.01%. Advantages of killed steel: there will be no evaluation of gas during solidification. Characteristics of high degree of chemical homogeneity. It will be marked with K symbol in the identification process. Increase in carbon content will increase the problem of non-metallic inclusion. Advantages of semi-killed steel. Structural steel containing 0.15 to 0.25 carbons are generally semi-killed. In semi-killed steels, the aim is to produce metal free from surface, blowholes, and pipes. The surface should have a sound skin of considerable thickness. They are used for general structural application. During solidification of semi-skilled steels, gas is evolved in the body of the ingot, tending to compensate in part or entirely for the shrinkage accompanying solidification. Since pipe cavity are minimized, semi-killed steels are usually cast in big and down molds with hot tops. This type of steel is suitable for drawing operation, except severe drawing. Equivalent carbon content or carbon equivalent CE. The equivalent carbon content concept is used on ferrous materials, typically steel and cast iron. Equivalent carbon content is used to understand how the different alloying elements affects the hardness of the steel being welded. To determine, and it is used to determine the various properties of the alloy when more than just carbon is used as an alloyant, which is typical. Carbon equivalent is calculated using the formula C plus Mn by 6 plus Cr plus Mo plus V by 5 plus Ni plus Cu by 15, where Ce is the carbon equivalent. C stands for carbon, Mn is manganese, Cr is chromium, Mo is molybdenum, V is vanadium, Ni is nickel, Cu is copper. The carbon equivalent is directly concerned with the weldability of the steel. If the carbon equivalent is up to 0.35, the weldability of the material will be excellent. If the carbon equivalent is between 0.36 to 0.40, the weldability of the material will be very good. If the carbon equivalent is between 0.41 to 0.45, the weldability of material will be good. The carbon equivalent, if it is between 0.46 to zero point 0.5, the weldability of material will be fair, and it will be if the carbon equivalent is over 0.50, the weldability of the material will be poor. Microing elements. The microing alloying elements like NB, V, and Ti may be added singly or in combination. Total microing element shall not be more than 0.25% of the total composition, where NB is niobium, V is vanadium, and T is titanium. Alloying elements such as Cr, Ni, Mo, and B may be added under agreement between the purchaser and the manufacturer, where Cr is chromium, Ni is nickel, Mo is molybdenum, and B is boron. In case of E600 and 650, the limit of Cr and Ni either singly or in combination shall not exceed 0.5% and 0.6% respectively, where Cr is chromium and Ni is nickel. Nitrogen content of the steel shall not exceed 0.012%, which is shall be ensured by the manufacturer by occasional check analysis. Lower limits of carbon equivalent and closer limits of other elements may be mutually agreed between the purchaser and the mechanical properties of structural steels. The table shows the mechanical properties of structural steels with reference to the grade, design, and the quality of IS 2062. In case of product thickness or diameter more than 100 mm, lower minimum limit of the tensile strength may be mutually agreed between the purchaser and the supplier. Bend test not required for thickness greater than 25 mm for grade E 300 to E 650, where T is the thickness of the test piece. For sub-quality BR, impact test is optional if required at room temperature, that is about 25 plus or minus 2 degrees. Selection and preparation of test samples. The position from which the test sample can be taken shall be so located in the product as to yield the clearest possible information regarding properties in the cross-sectional and longitudinal planes. The figure shows the position of test piece in different forms like angles, channels, tees, beams, and plates. Beyond plates beyond 12 mm in thickness produced from cutting of HR coil, the test samples for tensile testing shall be taken only in the transverse direction. Selection on location of test piece may also be mutually agreed between the supplier and the manufacturer. Tensile test. Tensile testing is a form of tension testing and is an inductive engineering and a material science test whereby controlled tension is applied to a sample until it is fully fails. This was one of the most common mechanical testing techniques. It is used to find out how strong the material is and how much it can be stretched before it breaks. Uh, in this IS 2062, the number of test samples should be 2 per cast per heat. The test specimen should be prepared with reference to IS 1608. This test should be carried out to find the yield strength, tensile strength, percentage elongation of the IS 2062, and when determined in accordance with IS 1608 shall conform to the requirements as per the table. If the gauge length and percentage elongation obtained is less than the specified, the test may be discarded at the manufacturer and supplier's option, and another test may be taken from the sample plate, strips, sections, flats, or bars. The detailed description about the tensile test will be given in a separate video. Bend test. A bend test is a simple and inexpensive qualitative test that can be used to evaluate both the ductility and soundness of the material. It is often used as a quality control test for butt welded joints, having the advantages of simplicity of both test piece and equipments. In IS 2062, number of test samples will be 2 per cast per heat. The preparation of test samples shall be prepared in accordance with IS 1599. The test sample should be greater than or equal to 40 mm. class of steel products, and direction of bend test. For plates and strips, the direction of bend will be in crosswise direction. The selection and type of test will be lengthwise for each specimen. Flats and bars will be of lengthwise direction. For bend test, the test piece at room temperature shall withstand bend through 180 to an internal diameter not greater than the table given without impact testing. The impact testing is given in the class 12 of IS 2062 Charpy V notch. The test shall be taken from the thickest product. If the test sample taken from the thickest product rolled from a cast meet the requirement, the whole cast shall be deemed to meet the requirements of the test. If not, the test shall be performed on the section on next lower thickness rolled from the same cast. If it meets the requirement specified, the particular thickness as other sections, lower thickness shall be deemed to satisfy this specification. If the thickness also does not meet the requirement, the test shall be carried out to the next lower thickness and so on, because the toughness of the products will depend only on the rolling direction as well as on the section size. If the average value of the three Charpy tests fails to comply the amount of exceeding 15% of the specified minimum average value, three additional test pieces from the samples shall be tested and the result added to those previous obtained and a new average calculated. Provided the new average complies with the specific requirement, the material represented shall be deemed to comply with this standard. The impact testing will be taken in thickness and diameter greater than 12 mm. The test specimen should be to the parallel to the direction of the rolling. Notch axis perpendicular to the direction of the rolling. Number of test samples will be 1 per cast per heat and the number of test pieces specimen will be of 3. Test is accepted if the average value of the 3 specimen meeting the requirements as per the table. Test is accepted no individual value is less than the 70% of that specified value as white groove crackability test. It is given in the class 13 of IS 2062. The Y groove crackability test may be carried out for a product or only E through 250 grade C material having thickness 12 mm and above, if specifically agreed between the purchaser and the manufacturer. The Y groove crackability test will not be applicable for rounds and it is mainly for plates and sections. Other test. Other test will be given in the class 14 of IS 2062. The material may be subjected to non-destructive testing to determine the soundness of the material, subject to the mutual agreement between the purchaser and the manufacturer. Metrological tests for grain size, directionality, inclusion content may be carried out subject to the mutual agreement between the purchaser and the supplier. Dimensions. Unless otherwise agreed to between the purchaser and the manufacturer, the normal dimension of rolled products conforming to this standard shall be in accordance with the relevant Indian standard. The Indian standard with the reference to the product relevant has been shown here. Tolerances. Unless otherwise agreed to between the purchaser and the manufacturer, the rolling and cutting tolerance of the steel products conforming to this standard shall be those specified in IS 1852, except for parallel flanges and beams columns covered by IS 12778, for which the tolerance shall be as per IS 12779. Other tolerances may be followed within the tolerance angles ranges as specified in IS 1852 and IS 12779 as applicable. Retest. If a test does not give the specified result, two additional tests shall be carried out at random on the same lot. Both retests shall be conformed to the requirement of this standard. Otherwise, the lot shall be rejected. Reheat treatment. If any heat-treated material fails to meet the mechanical requirements specified, the supplier may reheat treat the material and in that case, All mechanical properties shall be re-evaluated. Calculation of mass. The mass of the steel shall be calculated on the basis that steel weighs 7.85 grams per centimeter cube. Delivery. Subject to prior agreement between the supplier and the manufacturer, suitable protective treatment may be given to the material after rolling. A delivery schedule shall be given by the purchaser to the manufacturer for delivering of the materials. Marking on each product. The following marking shall be available on each product: manufacturer name or trademark, designation of steel, cast number, heat number will be marked on the each product. Other than this, a color coding shall be given which will be agreed between the purchaser and the supplier. BS certification marking. The material may also be marked with standard mark. The use of standard mark is governed by the provision of Bureau of Indian Standard Act 1986 and the rules and regulation made thereunder. Thanks for watching our videos. You can give your valuable comments in the comment box below. Like and share the video so it will be useful to others also. Don't forget to subscribe our channel and stay connected with us. Thank you.